Welcome to installment 9 of writing a 652 assembler in assembly language. And today, as I said last time, we're going to try to get string literals and names as tokens and return them. Once we do that, we will have gotten all the possible tokens. Maybe I forgot a few, but that will be all of the possible tokens that I have thought of so far. And we will be able to actually then read in a file and print out the tokenized version of it to make sure that the scanner seems to be working properly. So sorry about last time, which was maybe a kind of a boring episode. I was just going through trying to make sure I was using my getc subroutine correctly. Necessary, though it was necessary, because if I screw that up, then obviously we're not going to get anything at all, and we could have problems with unexpected end of file occurring in various places, which cause the assembler to do crazy stuff. We want to be able to make sure everything is handled properly. So that was just an unfortunate but necessary thing to do. So for today, we'll just start in here. We're going to go in here and look for get string literal first. All right, and I think it is get st, something like that. Get sterile, right? And we see this if we've gotten a double quote. So at this point, we've gotten a double quote, and we need to get the rest of the string until we get the next double quote, and then return our token is a string literal. Okay. So the first thing is we need a buffer to store the data that when we have a string literal, it could be, it looks like this. Hello world, with a new line perhaps, and even a null byte at the end. Okay, and we have to store this stuff somewhere while we're reading it in, because later we're going to have to output bytes which correspond to each of these things, the ASCII values for each of these characters and so on. And we could just have a buffer, right, which we could call, like, I don't know, just text buff, and make it 256 bytes long, because we're going to allow strings to be that long. But I actually, and if we're not running on an Apple II, then we could do that. But on the Apple II, we happen to have this 256 byte buffer available at location 200 hexadecimal. Like that. And from 200 to 2FF is a buffer which is used by many programs in the Apple II to input command lines. So if you're in the basic interpreter and you type in some line of basic code, it will be entered here. In the Orca command line environment that we're using here, when you type in your command line, it is stored here. And so we can use this buffer for the same purpose. Okay, so I'm going to get rid of this here and go put it up at the front right here. Call it text buff. So that will be at location 200 hexadecimal. All right, and now I want to just very quickly look for my token values. And I'm going to add here tstir. So that will be for our strings, right? And then I'll have to add here tnam. This would be for names. Oh, okay. Now the tokenizer will return, the scanner that say will return names for things like TOF, but for things like JSR, it's not going to return tname. It's going to return an actual token that indicates what this opcode is. So we'll come to that later though. I think it's get strl. Okay, here we go. Found it. Get rid of that. So get strl. It has already seen the beginning double quote. So we have to get a character. And now we will always remember to check and make sure whether it's EOF or not. So compare that to 0. If it is not EOF, I mean if it is EOF, right, y is not 0, then we'll go to get strl 9, in which we will just unget that EOF. Okay, and we also then we have an error here. Yeah, we have an error here that we have an unterminated string literal. So that means that we're going to have to have an error message. Stir error. I'm sorry, what am I doing here? This has to be okay. Now stir the error subroutine itself is going to try to scan, basically purge the input until it gets to an end of statement. So I guess I really don't need this ungetc here, because what would happen if I unget it? It's when the error is going to print out the message, and it'll start reading. It'll say, "Oh, I got an EOF," right? But even if I don't ungetc here, it'll get an EOF. Right? At least it should work that way. So I can just say, okay, there's a string error. All right, and the string error unterminated string. Okay. Okay, so assuming it's not EOF, okay. Actually, what I need to do here first off is get strl and then do load x with 0. X is going to be our index into the text buff. Okay. Oh, right. But x is going to get whacked by this subroutine. It's going to destroy x. So what I'm going to have to do, well, I mean, there's multiple ways to do it. I could keep x and just like push it onto the stack, but that causes a problem here, which is really annoying. I might end up changing this, but for right now, I'm going to go ahead and keep my index. No, I'm not going to push on the stack. Okay, I'm going to load x. I'm going to store that into get strl, let's say 1. because this here will probably be get strl 0. Okay. Start get strl 1. So if it's an EOF, then I go down here and do this stuff. If it's not an EOF, then I'm going to, and this is where I have my get strl1, and sorry, this should be +1. I'm going to load x, not with 0, but with whatever gets stored here. Well, okay, will it be 0 initially? Okay, and then I will store the character I got into text buff, comma x, and then I will increment this byte right here. All right, and if that, now I have to say if that is equal to 0, there's a problem. So I'll go to get strl2, which would be right here. If that is not, if it did not become 0, then I will just, actually I don't need to do that. If it's not 0, I'll go get another character. Go up here. That's not quite right either, is it? I think I'll leave it like this for now. Okay. Okay. So get a character. It's not EOF. Load the index, which starts at 0, but it's going to get incremented here. Use that to store into the text buff. Increment the index. If the index becomes 0, then basically the string is too long. If the index is not 0, then actually if we want to go get another character, but now I'm just thinking of something else. Okay, so it's not an end of file. So actually before we do this, we need to check and see. It's not end of file, but is it a double quote? Because if it's a double quote, we're done. Okay. So double quote is done. And for now, I'm just going to make it the same get strl2, because here in this case we're done because we got a double quote. In this case we're done because the string's too long. So they're both cases of done, and the code here might be the same. So I'll just leave it that way for now. Okay. So get a character. If it's not an EOF, then is it a double quote? If it is, that's the end of the string. Otherwise, we're going to store it into the text buffer with this index, which gets incremented every time here. And if this index overflows to 0, that means the string is 256 bytes long, or it could be longer in the text, but I mean it's too long. That's the important part. So we're just going to go down here because we're done. We're not going to get any more of the string. It's too long. Okay. Otherwise, if it's not a double quote and the string isn't too long, we can go back up here and get another character. So actually, I could just say here, if it's not too long, that is to say, if this index has not just become 0, I can go back up there. Okay. Okay. Now we actually have another issue here. We have to check for backslash. And if it's not a backslash, we just go here and store it. if it is a backslash, we're going to do the same thing we did here, which is call it getc. Okay? And when we call getesc, let's just go look at that. It's going to get a character. Okay. Looks like I never finished this. I was distracted at the time because, as you may have noticed, I got a phone call right at this point. I had to stop recording for a minute and check, but I never actually went here. This is the part where we have an EOF, remember? So right here, what I need to do is compare y to 0. And if it's not equal to 0, I go to get esc7. Okay, so now we're coming from the string. We got a backslash. We get another character. If it's an EOF, go down here. We're going to unget the EOF and return a backslash. And otherwise, we're going to store the character we got here because we're going to use this to compare through the table and blah, blah, blah. So it's going to return something which is a valid character of some sort. Either it's the mapping from the table, it's just whatever character was after the backslash, or it's a backslash itself when we get an EOF there. It will return that in the accumulator, so when we come back from this subroutine, it'll be there and fine. So this looks okay. All right, now we have, this is the case of we're done, either because we got a double quote or because the string's too long. Now, what we want to do here is if we get a double quote, X is, this thing here is always, like we put a character in the buffer at this location, whatever it is, and then we increment this thing. So it's always putting one past the location of the last good character we put in the buffer. Which, if we get a double quote, is beautiful, because then all we need to do is just store a 0 in there, and I guess we could do it with A. In fact, we should do it with A. And store that in there. So this is null terminating. Actually, we don't know what X, sorry, we can't be sure that X is there. We have to load X with, we have to get this byte right here. Okay, so load A with 0, get this byte, whatever it is, and then store our thing there, right? But we have here the issue that if we increment this thing, it becomes 0. Okay, and if it's not 0, we go up here. If it is 0, we want to back it up 1. So that means we can put here okay. So we take a valid character, we get the current index into the text buff, we store a valid character at that index in the text buff, we increment this index into the text buff. If this has not just become 0, then we haven't overflowed the text buff. So we just go back up here and get another character. If this thing did become 0, we have to decrement it back down to FF, hexadecimal FF, or 255 decimal. The reason for that is that we now are going to put a null byte at the end of our text that we got. And that null byte cannot be in 0. That would mean we got a string of length 0. Instead, we're going to back it up here to say we got a string of length 255. I mean, actually, there were 256 characters that we received after the double quote before we got another double quote, but we're just going to stave that first 255 as a string literal. Okay, and we'll store that. That null terminates our string. And now all we have to do is load the token tstir and return it. So when the parser sees that it has a token t-star, that is a string, it will know that the text for that string is in the text buff, this thing right here, and it can grab that when it needs it. All right, now we can delete these lines. This is the situation where we get a string error. There's like an EOF or whatever in the string. Okay, and we also have one other situation that can cause this, and that's if we get a new line in the middle of the string. We're not going to allow that. So if for whatever reason in our text file we have something like hello and then a new line, all right, then that's going to be an unterminated string constant, or string literal also, unterminated string. So what we have to do here is just check and check for that as well. Okay? And that is to be either 10, which is the ASCII new line character, and we'll go to get strl9, or it is going to be a 13, strl9. Actually, we should do this. Yeah, we have this whole issue of what happens. That's the problem with these type of things. There's always these issues. What happens if? What happens if? What happens if? And of course, these things are almost never going to happen. But you know, if someone gives us a crazy source file that has control characters inside a string, then we should deal with it in some reasonable way, right? And with some reasonable way, which is, like, as I say, our assembler shouldn't crash. It should recognize there's a problem and deal with it somehow. So this means if we get an EOF or we get a new line character or a character string character, we're going to say it's an unterminated string constant. And now that I'm doing that for the new line stuff, I'm going to go ahead and put that unget back in here, because I don't care about ungetting the EOF, but I would like to unget a new line or a character turn. Okay, ungetting the EOF won't hurt anything. I'm just saying it's, but I didn't feel it was necessary, but it is necessary to unget a new line character. So now we have the issue of what if it's just not a printing character at all that's in the string? What if it's a control character of some sort, right? And that could be true of many other places. It could be true of the character constant here. The other things, I haven't really thought about that. I haven't worked on, like, so far I haven't said, well, what happens if I have a decimal constant, I get a control character? Well, that's actually okay, because I start the decimal constant and I say, okay, if I get a control character, it's not a decimal digit, so I just put it back, I return the decimal digit, then the next time I start to scan again, it's going to get that and say it's a bad character. I did handle it in that case. But inside of a string, I'm not handling it. So what I should do is compare it to a space. If it's less than a space, the space is the first printing character in ASCII. If it's less than a space, I'm going to go to a different label, which will be another type of error label. Okay, the other possible control character is an ASCII 127, which is the delete character. So what I'm saying is, if I get an EOF, I go to unterminated string constant. If I get a new line here or here, character return, unterminated string constant. If I get a delete character, which is a control character, I go to bad character and string. And if I get something which is less than a space, which is a control character, but not these control characters, then I'll go to bad character and string. Then otherwise, I just check for a double quote to end the string or a backslash for an escape sequence. Okay, and I will unget that bad character, whatever it is. And I had an error, bad character in input. I can just reuse that same error. Okay. So that looks pretty good. The character constant, yeah, we could have an issue with a bad character in the character constant or escape sequence. So I probably should look at that, and but I won't do that next time, maybe, or a different time. Okay. What I want to do now is look at names. And I put the label for that up here, get name. So I'm going to go ahead and delete that. And move it down here. To get right after getStir, because it's going to be pretty similar to getStir. Not exactly the same, but similar. Okay. So with getName, I have really, the reason I say it's similar is, in fact, you know what I'm going to do? I'm just going to get rid of that. I'm going to copy and paste all this stuff and then take away the stuff I don't want. Okay. All right. Delete, no, don't delete them. Okay. Okay, because it's going to be quite similar here. Okay, so same thing. I'm going to use the same method for storing the characters I receive in this text buffer. Okay, and get name 0. If it's EOF, I'll go down to get name 9. If it's a now in this case, now this is, we don't have to worry about the new lines. If it's a name at the end of it with a followed by a new line is fine, right? Like what if I have, well, like for example, I have just JSR new line. I mean, that's fine. JSR will look like a name. At this point, it's considered a name. Later, we'll have to look through the table of words which are not names and figure out this is actually a JSR opcode, not a name. But it's fine to have an or a label. Actually, a label will be followed by a colon. But anyway, we can have a name followed by a new line. That's all fine. So we won't bother with this. Okay, if we get a name, right, well, if a new line will just be not a character that can appear in a name, and so therefore it will not be, we'll just put it back and we'll return the name as it is. I just forgot something. Remember I had said we're going to enter the name with the first character already in the accumulator. So that means this is going to have to be a little bit different. But I'll remember that in a minute. So let me just do that. I need to not forget that. Because when we go into get string literal, all we've gotten is double quotes. So we have to start from nothing getting the actual characters in the string. In this case, we're entering new name. We're entering get name with the character already in the accumulator, although we could possibly I'm flip-flopping back and forth. We could go back up and change that so that I just have to unget the character up above, and then we would not have to worry about it. I might do that. I might go back to the old, I think one way, then think another way. Anyway, if it's an EOF, we'll go to get name 9, which is, actually, that's actually not a problem either. A name followed by EOF could be valid. So that will simply be, there's not going to be an error here. This is just going to be RTS. We'll see what happens in a minute. But anyway, this. Okay, so if we're at the end, we're finished getting the name, we're going to unget the character, which is not a character, which can be a name. It's not a letter or a dot or an underscore or a digit, and we'll return the token name and return. Okay. That's true of all these things. If we get a bad character, that's just the end of the name. I don't have to worry about it. Okay. And of course, we don't care about double quotes or backslashes and so on there. Okay. So what we do care about here, though, is whether it's a valid character for a name. So if we get EOF, that means that we unget that EOF and return name. Otherwise, if we don't get an EOF, we have to check and see, like, okay, so is it a dot, right? You know what? Why should I write all this stuff out again? Okay, so let me go up to the beginning of the file. And copy this. And I think, you know what I'll do here is I will just go ahead, as I said before, okay, go ahead and unget that first character from the name, and then jump to get name. So I first had it this way, then I changed to say, no, we'll just call get name with the first character already in the accumulator. Now I'm changing it back because I'm wishy-washy that way. But now I'm going to go ahead and copy and paste this stuff because I don't need to repeat this, basically. Don't delete it. All right, and then search for get name. Here we are. Okay. Actually, it doesn't need to be here. Let's get rid of all that. It needs to be here. All right. Okay. All right. So get a character. Now I know for a fact, because of what I just did above, that the first time I call getc, I'm going to get a valid character for a name. I'll end up checking again, but that's not a big deal. So is it EOF? If it is, go down to get name 9, which is here. Okay. Otherwise, if it's a dot, that's a valid character. So we'll go here. This would be get name 1, right? So I'm doing it here. So instead of going to SC name, it would be get name 1, get name 1. All right. Okay, if it's here's saying if it's greater than a z, a lowercase z, it's no longer a named character, so it's going to go here, get name 9, unget that thing, and return the name. Okay, here it's a valid character, get name 1. Here it's an invalid character, which will mean it's the end of the name. And if it's less than a, it's also not a correct name. But this is now actually wrong because I have to add digits in. So what I really want to do is compare it with a, and if it's greater than or equal to an a, I want to go to get name 1. Okay, and now I want to compare to 9 plus 1. If that is to say, if it's greater than a 9, it's not a valid name character. And now compared to 0, if it's less than a 0, it's not a valid name character. Okay. So this checks for all of the characters that are valid characters for a name. And if we get valid characters, it goes here to get name 1. If we get something which is not a valid character, it goes down here and ungets the invalid character and then returns the token name. There will actually be a little bit more to do down here in a minute, but anyway. Okay, now we're going to, again, load this index, which is our index into the text buff. It starts out as 0 right here. Store it in the text buff. We have to increment that index. Okay. And if it did not overflow, we can go back up here to get another character. If it did overflow, then we're going to decrement it, just like we did for the string. And here is the place. Now, in the string code, I came here if we got a double quote, but I don't have to do that because there's no such thing as a double quote in the name. Anything which is not a valid name character sends us down here. This is where we're null terminating. I see. Okay, hang on. So actually, this kind of belongs down here, right? This kind of belongs down here. So this could be actually get name 9, which is unget a character. Okay, null terminate the name that we just got. Okay, and then load, tstir load tname return. Okay, and this was in the string code. This is where we got a bad character in a string, like a control character or something. But we don't care about that here, because if we get a control character, we'll say, well, it's not a part of the name, so we just unget it and return the name we got. And then after that, when the next time we try to scan another token, it will get a bad character, so we don't have to worry about that. So maybe I shouldn't have copied and pasted this string code, because this was kind of different. The only thing we really kept is this whole idea of storing our index into the text buffer here, and this code is the same basically. Okay, so that means we now have gotten a string and we've gotten a name which could be a, you know, a label like this, or it could be an opcode like CMP or anything like that. Okay. Let me just look real quick here. I was talking about the situation. What if we get a control character here? Okay, so we get a character. We've gotten a single quote already. This is in the character literal. We get a character. It's not a new line. I mean, not an EOF. So we look for a backslash. If it's a backslash, we're going to go up here to the escape sequence thing. If it's not a backslash, we decide it's good and we return it. But actually, we should probably check to see if it's a bad character, like it's, okay, so, all right, so we should compare to see if it's a delete, a control character. If it is, we're going to go to I'll just say 9. Okay, and then we compare it to a space. If it's less than a space, it's a control character, so we're going to get CHRL9. Okay. So we have, that's the issue we have here. Control characters are going to get CHRL9. And I'm thinking we might just want to have that come down here. Here, sure, bad character. Yeah, I'm sorry, come to here. This is where we get, this is the one for a bad character. This one here, get STRL8. That's too far to branch. So we could just say get CHRL9, jump to get STRL8. And maybe I'll make this 8, just so it's 8 and 8. So if we get a control character, either a delete or some other control character, we're going to go down here, which will then jump to get STRL8, which says, okay, it's a bad character in the input. But there's also the issue of what if we get a new line or carriage return or something like that. Then we actually, that would just be called an unterminated string, an unterminated character literal. So we should check for those too. And that's right down here, at this point right here. So if we get a new line, then it's an unterminated character constant, which is an error. If we get a carriage return, then it is an unterminated character literal. Like so EF, EOF, or new line or carriage return is an unterminated character literal. It goes down here. Okay. Now, in an escape sequence, so if you get a backslash followed by an EOF, we already thought about that. We're going to unget it and return the backslash. But you know, I'm just thinking, maybe it would be better if we get something like this. My chart equals, now we have backslash EOF. maybe instead of returning the backslash, we should just call it an unterminated character literal. Same thing as if we get backslash new line. That, I think, should just be an unterminated character or string literal, depending on which one it is. That's kind of the problem, isn't it? Because we call this from both character and string. Well, we could, yeah, I think we'll do it like this. Okay, so I'm going to, so if it's an EOF, then yeah, it's a problem. First check for that. Then check for the backslash. If it's not a backslash, then we will go to get chrl0. If it is a backslash, then we'll JSR get escape sequence. Okay. And then we'll check not only what came back from, if it's not a backslash, but also whatever came back from the escape sequence. We'll let all that run through this same checking here. So that will be get chrl0 here as well. So whether we get an escape sequence, like if it's not an escape sequence, we'll go right down here and start checking to see if it's a new line or it's a control character or whatever. Even if it is an escape sequence, we'll still check if the result of this is a new line, a control character or whatever. Okay, that means this goes away. And that goes away. And this goes away. Okay, so no matter whether the character comes directly or it comes through an escape sequence, we're going to check against all these things. And assuming that everything works out, then we're going to go ahead and push it and then check for a single quote, insert into the string, and so on and so on and so on. So what we just have to do is make sure that the getESC subroutine itself, if it gets a control character or an EOF, it just returns that. It returns that. So up here, if it gets EOF, it ungets the EOF and returns a backslash. We don't want it to do that anymore. We should actually just check for EOF here again. So getESC will return an EOF if it gets an EOF. So if it gets EOF, then we will go down to get chrl2 unterminated sequence. So okay, get an EOF. So actually we can say if it is not an EOF, then we'll go right here. Okay, so we get a character. After the backslash, we get a character. We check to see if it's EOF. If y is equal to 0, it's not an EOF, so we go down here. Otherwise, it is EOF, and we just return. And that will return that EOF in A and Y to the caller of getESC. That means this goes away. Okay. Here we store the character we get. Now actually what we need to do here is check to see if we got a character return, new line, control character, all that stuff. Okay, and here I don't care about actually checking for character return and new lines separately from other control characters, and I maybe don't care about that in the character literal stuff. We'll see. I'm just going to compare to 127. Okay, so if it's not a new line, it goes down here. I'm sorry, if it is not an EOF, it goes down here. But actually that needs to be here now. Okay, get a character, see if it's a new line. If it's not a new line, go down here. If it is a new line, just return. It's not a new line, see if it's a delete. If it is delete, just go here and return it, the delete. If it's less than a space, it's a control character. Return it. Okay, I can foresee this changing very soon, but at the moment. Okay, so here, so this will also control, like new line and character return will be handled by this case right here. Now it's not a control character, it's not an EOF. We'll store it. We will start looking through the table. We'll compare the table characters against the one that we got. If we find the mapping, then it'll go down here and load the value from the mapping. Otherwise, it'll just end up coming here where it returns the character we got after the backslash. Okay. All right, good. And what we'll do here is I'll just make this that's called getec6. So these things will branch down here to return. And here, we're changing this again now. If we get a new line, EOF, sorry. Compare Y. If it's not equal to 0, it's an EOF. We just go to getec6. That means this can go away, that can go away. This can go away. Okay, so let's just go over it real quick. At this point, we've gotten a backslash, we get another character. We see if it's EOF. If it is EOF, that means Y is not equal to 0. We just return the EOF. We compare, it's not EOF, we compare the character to a delete. If it is a delete, we return the delete. We compare the character to space to see if it's less than a space. If it's less than a space, it's a control character, and we return the control character. Otherwise, it's a printing character, and we go through this process of looking it up in the table. This is where it goes if it's mapped in the table to something else, and this is where it goes if it's not mapped in the table. That all looks nice. Okay, here in get character literal, we're getting a character. We see, is it an EOF? If it's an EOF, we go down here, which is an unterminated character constant. If it's a backslash, if it's not a backslash, we just skip down here. If it is a backslash, we go to getec to look for an escape sequence. And then coming back from that, we could have an EOF or a control character. So we check for an EOF again. If it's an EOF, it's an unterminated character constant here. If we did not get an EOF from getec, we start checking. Is it a new line? Is it a character return? If so, we get an unterminated character constant error. That's here again. Okay. If it's any other control character, then it's just a bad character in the input, not an unterminated character constant. So we'll go to get CHRL8, which jumps to get STRL8, which actually prints out the message. Otherwise, it's a good character, and we remember what it is. We look for the single quote. If we don't get the single quote, then we're going to have an unterminated character constant. And if we do get the single quote, then we return a number token, but we've put the ASCII value of that character that we got in the tokeval. All right, that all looks pretty good. I'm gonna end here for today, and off screen, I'm gonna look through this code and just make sure that everything looks fine. If it doesn't look fine and things need to be changed, then next time we'll work on fixing the problems I find. Otherwise, if everything looks good, next time what we'll do is we will try to write some code to print out the tokens that we get, and then we will try to tokenize a source file and see if the scanner works correctly. So that's the goal for next time. Either one of those two things, fixing problems I find or going ahead and checking the proper functioning of the scanner. Until then.